for today. And this question is going to help out with the calculations that you're going to do to be ready for the lab. So what I'm going to ask you to do is to write this down. And I am going to ask you to try to start doing these calculations before I tell you. So the question for today is, you are going to prepare a solution with a specific molarity. Ooh. I just misspelled that. What happens if you want to make, let's say, 375 milliliters of a solution that has a molarity of 1.25 molar of sodium chloride? What would you need to do? So that's my question. If you would need to make this solution, what would you need? So I'm thinking materials, but I'm also thinking numbers. Okay? I gave you some formulas and a couple of conversion factors that are going to be useful for what you're going to be doing today. Hello, this is Aracelys. Okay, I'll let you know. Angel, you're going home? Thank you. So I am going to, like I said a moment, I put this back so you can work on these for the next day. So this is similar what you're going to be looking at. So that's why I wanted to kind of get in a moment and do some of these calculations in there. So you're going to make a solution of a specific concentration. The interesting thing is that every group is going to have a different concentration. It's not going to be sodium chloride, it's going to be a different compound. That is okay. We should be able to find molar masses of any compounds by now. Okay? You need to make it a little bigger, Marley? So let's see if you can start just writing some notes to yourself about what do you think that you're going to need to be able to do this. I'll give you 30 seconds to do this, and then I'm going to ask if anybody has an idea. So sodium chloride is a salt, it's a solid. Okay, so I hope that that helps. Today you're also going to be using a solid to make your solution. Any ideas? Any suggestions? Suggestions? Any? What do you think you need to calculate first? Oh, really, guys? You have been shy today. What do you think you're going to need?
The mass
The mass of what?
of Aracelys.
Okay, good. So, how can you do that? Can you find the mass of NaCl? What would you need in order to find the mass of NaCl? Okay, so volume, I like that. But instead of density, what is the other thing that we have been looking at? Look at the question. The volume and the? Okay, so we want to do moles. Good. Anything else? Huh? Okay, so what is the solute? Okay, I like that. So there is a lot of vocabulary in here. Notice that we are going to keep looking at our vocabulary back. Okay? Anything else? There is one more thing, one more information that is there. What about this number? Oh, I like that. So we have this number and we have something with liters. What? We really don't have liters, do we? What do we have?
Milliliters.
Do we need to change it to liters?
Yes.
Yes? Do we? Why?
Because it's moles of solute divided by liter.
Liters of
The solvents.
solution. And that is going to be an important part of considering today. So molarity is equal to moles of the solute. So what is the solute today in that problem? What is the solute?
Sodium chloride.
Good. So in this case, the solute is sodium chloride. And it's going to be divided by the volume of the solution. That is going to be, then one is in liters. Okay. So I gave you milliliters. Can we change milliliters to liters? Yeah, can we? Yeah. Do you know how to do it? You remember how to do it? We've done this before. Okay, good. So remember that we have talked about that. Remember dimensional analysis? Do you see that? It says 1 liter is 1,000 milliliters. Which part goes on the bottom? The liters or the milliliters? What do I want to cancel? We want 2 liters at the end, no? So then 1 liter goes on top, and this goes on the bottom. Yes? Do you notice that the milliliters cancel with the milliliters? So what would be the answer to this question, to this problem in there?
375.0 times 1,000.
Divided. Can you see that? Because it's going to be 375 times 1 divided by 1,000. So what is the answer to that? Anybody? 0.375 what?
Liters.
Liters. Remember that anytime that you do something like that, if you put it correctly, it will give you the units that you need. So now we have, so what can I do? In order to be finding the mass, what do I need? Moles. So if I have mass, how can I find moles? What do I need to use? I gave you another piece of information in there.
Total moles in the solute.
Okay, so how can I find the moles if I have these? I gave you the molarity. And I have the volume in liters, no? Do I have the volume in liters?
Yes.
Yes, how much is it?
375.
So why do I get in here? What do I have to find in here? So can I reach and rearrange this formula to find moles? No, in this case, no. Because there is a difference, and I wanted you to say something like that between here, when I was doing a conversion factor, and here is a mathematical formula.
Oh, because it equals something?
Yeah. So in here, in this one, I was using a conversion factor, like this one. But now, do you remember when we calculated density, was it mass divided by volume? Remember at the beginning of the semester? Yeah? So you were able to calculate mass, if you had density and volume. So the same thing. So how can I find the moles in here? Moles is going to be equal to what? Try it. Moles is equal to what? Or can somebody find the moles for me? No? So if I have moles in here on top, and I have these, what are moles equal to molarity multiplied by volume? You remember do you remember these from before? You guys? Yeah? Yeah? You
Yeah.
remember something that we did like that? Okay? So you can rearrange formulas in whichever way you want. So moles is equal to molarity multiplied by the volume, and the volume has to be in liters. So how many moles? You got your calculators in front of you, how many moles? You got your calculators in front of you, how many moles? Everybody should be doing this. Grab your calculator.
0.47.
How much?
0.47.
0?
0.47.
So you're doing 1.25 multiplied by 0.375?
Yeah.
Okay? And then let's say, I gave you 3 sig-figs, I gave you 3 fig-sigs, so we should be able to use another one.
0.468.
468?
Just round.
That's okay. But remember that we talk about sig-figs? That if you start with 3 sig-figs, you find a number to have 3 sig-figs? I don't want you guys to be quiet. I want you guys to be answering questions. Why are you so quiet today? So those are the number of moles. So if I have moles, how can I find grams? If I have moles, I can find grams. So I have, why is this not, it's taking a little bit of time. Uh-oh. If I have moles, how can I find grams? What do I need to use? 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 The water mass, thank you. We have done this before. So if you have moles, well, this is kind of being a little weird today. Okay, let me just continue on the board. I was just trying to do this because then I'm going to have to go a little bit too long. So if I have 0.468 moles, and these are moles of sodium chloride, no? Because we said that it was the moles of the solute times.
1 mole.
Now I'm going to use that conversion factor. The 1 mole of sodium chloride is 58.44 grams of sodium chloride. Which side goes in the bottom? The moles or the grams?
The gram goes on the bottom.
The grams go on the bottom? What goes on the bottom? The moles or the grams? Remember that if I want to cancel moles, the moles go on the bottom. Okay? So then 1 mole of NaCl is equal to 58.44 grams of NaCl. So you can see,
What is next to the 6? Is that,
which 6? Oh, again, is this a number? Is this number?
no, on top of the,
Oh, is this number? This is molar mass. 58.44 grams.
oh,
I know, it's kind of hard to write down when it's so low. So let me do this. So, give me this number. Give me this final number. Calculator. Give me this final number. So what are you going to do with the numbers? You're going to multiply? Okay, so give me something. How much? 27.92. Okay. 992. Okay. So now remember, I started with 3 sig-figs. How many sig-figs do I want to have at the end? 3. Okay. So I keep this number, I keep this number, I keep this number. So it's going to be equal to 27.3 or 27.4? 27.3 or 27.4? 0.3. And those are going to be grams of sodium chloride. Okay? What happened, Alejandro? Why are you making that face? It's I think? Okay. So, in order for us to really get to do this, you're going to do it. Yes, you are. Yes, you are. So, what you're going to happen is, ¿la quieres en español? ¿Lo quieres en español? Lo tengo aquí abajo. Okay, sí. So what we're going to do is, you're going to grab, like before, your partner, your small group, and you're going to do this. You are going to design an experiment to produce a solution with lemonade of a specific modality. Every group is going to get a different number. ¿Lo quieren en español o en inglés? ¿En español? ¿Español o en inglés? También les recomiendo que lo agarren en inglés para que empiecen, hagan un poquito más esa conexión. Tengo un par de copias en español. ¿No me acuerdo cuántos aquí en español? La comparten con Aaron, ¿ok? Oh, did I give you one in Spanish? ¿Se las di en español también? No. Okay. Oh, ese es el tuyo. Oh, okay. Okay. So, when you are ready, you are going to come and get materials from me to do this. So, notice that I'm asking you. Notice that I'm asking you to write the names of the people that are working with you. So when we are doing this together, I can check. Oh, I don't know why is this being a little weird today. Dígame.
We didn't get any paper.
Oh, I did not give you one paper. I forgot about you. It's been a long day. You know, guys? Okay. So let's read through these and let's see what is it that I'm asking you to do. I don't know. Why this is being weird today?